This tutorial review will cover translating words to math. To begin, we will review important vocabulary for translating words to math. An algebraic expression consists of two or more terms that include one or more variables. An example is 5x squared plus 3x minus 2. A way to remember this is to know that the root word of algebraic is algebra and it must have one variable. The next vocabulary word is terms. Terms are numbers or variables separated by a minus or plus sign. In the example, the first term is 5x squared, the second term is 3x, and the third is 2. To remember this, think of the number terms you have in school, with each term being separated. Coefficients are numbers multiplied to a variable. As shown in the example, 5 is multiplied by x squared and 3 is multiplied by x. So the coefficients are 5 and 3. The constant is a term that does not have a variable. In the box that is located to the left and is labeled example, the 2 is the only term that does not have a variable, so it is the constant. To remember this, think of a constant as not changing. No variable is multiplied to it. Let's look at an example. So we have an expression 4x squared plus 3x plus 7. If we want to find the terms, we look at the definition of terms. And the definition is that the terms are numbers or variables separated by a plus or minus sign. So, what is separated by a plus or minus sign? We can see that 4x squared, 3x, and 7 are all separated by plus signs. So, therefore, they are the terms. The coefficients are 4 and 3. Remember, constants do not change. So 7 is our constant because it is not multiplied by any variables. Here's example 2. The expression is 5x squared plus 1x minus 2. The terms here are 5x squared plus 1x minus 2. The coefficients are 5 and 1. The constant is 2. You try. Complete the table for the following expression. 9x squared minus 4x plus 7. I will give you some time to finish it. Here are the solutions for the expression. Let's check your answer. For the expression 9x squared minus 4x plus 7, the terms are 9x squared, 4x, and 7. The coefficients are 9 and 4. The constant is 7. Here are some keywords to use when translating verbal expressions to algebraic expressions. Remember, there are different ways to say add, multiply, subtract, and divide. Let's look at other ways to say add. Altogether is an example of another way to say add. Also, increase, more than, plus, sum, total, and and. Other ways of saying multiply is per, times, product, or double. Subtract has different meanings as well, which are difference, decrease, less, less than, or reduce. Now, if we want to find another word for divide, as shown in the box to the left, we see that quotient is another word, divided by, divided into, or split. Let's translate the following verbal expressions to algebraic expressions together. Number 1, 5 more than x. More than means to add, so x plus 5 should be your solution. The quotient of x and 2. Quotient means divide, so x over 2 would be your solution. Number 3, 2 less than 7 times a number y. 7 times a number y is just 7y. And less than 2 is just minus 2. So your answer should be 7y minus 2. Number 4 says 3 more than the product of 4 and a number x. So 4 times the product is 4x. And 3 more is 3 plus 4x. So 3 plus 4x should be your solution. Number 5, Sarah's age, A, decreased by 2. Decreased by means to subtract. Therefore, A minus 2 is your solution. Let's try a few more. Number 1, 12 more than the product of a number x and 5. Number 2, the quotient of a number and 11. Number 3, 7 times the difference of a number and 6. Number 4, 13 times the sum of a number and 8. I'll give you a few minutes to try these. Let's check your answers. For number 1, 12 more than the product of a number x and 5. Your solution should be 12 plus 5x. Number 2, the quotient of a number n and 11. Your solution should be n over 11. Number 3, 7 times the difference of a number x and 6. Your solution should be 7 times the quantity of x minus 6. Number 4, 13 times the sum of a number y and 8. 13 times the quantity of y plus 8 should be your answer.